Hello everyone, I am Sindhu studying in Sri Venkateshwara College of Engineering 7th Sem ECE. Today I am going to discuss about a topic called operation of MOS transistor in accumulation, depletion and inversion mode. As we know that MOS metal oxide semiconductor transistors are a fundamental components of modern integrated circuits, commonly used in a digital logic gates and analog amplifiers. They are they operates in a three different modes: accumulator, depletion, and inversion mode, depending on the voltage applied to the gate terminal and the resulting charge distribution within the transistor. In this below diagram, we can see the MOS transistor. We have a three terminals: source, gate, drain, and body is a p-type substrate, and W is the width of the MOS transistor, and L is the length between metals. MOS transistor in accumulation. Now we are discussing about accumulation layer. This is the first diagram of accumulation layer. The voltage applied to the gate terminals in such that it attracts the free electrons from the semiconductor substrate towards the surface beneath the gate oxide layer. This creates a layer of excess electrons or an electronic accumulation layer just below the gate oxide. The presence of this electron accumulation layer forms a conductive channel between the source and drain terminal of MOS transistor, allowing a current to flow from source to drain. In this mode, the MOS transistor is on and it conducts a current easily. It typically operates with a positive gate source voltage VGS. Here we can see Vd is less than Vg minus Vt. Vt it is the threshold voltage, Vg it is a gate voltage, Vd it is the drain voltage. Drain voltage is less than a gate voltage minus threshold voltage. In depletion mode, the voltage applied to the gate terminal is negative but not strong enough to invert the channel. Instead, it creates a small region of depleted charge carriers, both electrons and holes, beneath the gate oxide. The depletion region reduces the conductivity of the channel, making it less conductive compared to accumulation mode. Depletion mode. MOS transistors are not commonly used in digital applications but can found in some analog circuit designs. They operate with a negative gate source voltage. In inversion mode, the voltage applied to the gate terminals in negative but not strong enough as in the depletion mode. Inversion layer just beneath the gate oxide. The inversion layer forms a conductive channel between the source and drain terminals, enabling a high flow of current. Inversion mode MOS transistors are most commonly used in digital logic circuits. They operate with a negative gate source voltage VGS for n-channel MOS transistor and a positive for p-channel MOS transistors. Next topic, NMOS fabrication steps. In NMOS fabrication steps, we have 9 steps. The step-by-step procedure of NMOS fabrication steps including the following. In step 1, we have a Si substrate in the below diagram. Processing is passed on a single crystal Si of high purity on which necessary P impurities is initiated as the crystal is developed. The diameter of such wafer are about 75 to 150 mm and 0.4 mm thick, and they are doped with the say boron to impurity observed of 10 to power 15 centimeter cube to 10 to the power of 16 centimeter cube. In step 2, a SiO2 silicon dioxide layer, normally 1 micrometer broad, is grown all above the exterior of the wafer to guard the surface, performs a barrier to the dopant through processing, and offers a generally protecting substrates onto which extract layer may be deposited and decorative. First step, we have a Si substrate. Above that surface of S substrate, we have a SiO2 oxide. It is a insulator. In step 3, the exterior surface is now enclosed with the photo opposite is deposit onto the wafer and to an even distribution of necessary thickness. Above the surface of SiO2, we have here a photoresistor. In step 4, the photoresistor coat is then uncovered to ultraviolet UV light through masking, which describes those areas into which transmission is to take place on which transistor channels. When the photoresistor surface is exposed to a UV rays, then it makes a N masking. For example, that those areas uncovered to UV radiations are polymerized, but the areas necessary for diffusion are protected by the cover and remain unchanged. In this below diagram of step 4, we can see the UV rays and separation of N mask. In step 5, these regions are consequently readily fixed away together with the original silicon dioxide so that the surface of wafer is uncovered in the window defined by the mask. Here we can see the applying a UV rays. We are separating the N, we are separating the photoresistor. In step 6, a thin layer of SiO2 0.1 micron m typical is grown over the chip surface after removing the remains of photoresist. Further, a gate structure is created by depositing polysilicon on the top of it. Factors like precise control of thickness, impurity, concentration, and resistivity are necessary for the fabrication of fine pattern. Here we can see the diagram. Here we have SiO2 oxide. Above we have a thin oxide. In step 4, further the photoresist coating and masking allows the polysilicon to be patterned. After this, the thin oxide is removed to expose the areas. These areas are diffused with N-type impurities by heating the wafer to high temperature and passing the gas of desired N-type impurities to form the source and the drain. Here we can see the seventh step. In eighth step we have again a thick oxide of SiO2 is grown over and then masked with a photoresist. Now it is etched to expose a selected area of the polysilicon gate, drain and the source where connections are to be made. Here we can see the eighth step. Here we have a insulating oxide and SiO2 oxide. Here the N plus channels are created with the source and the drain terminals. Here we have a SiO2 Si substrate. In step 9, now the whole chip has the deposit of metal aluminum over its surface, typically to a thickness of micron m. This metal layer is masked and then etched to form the required interconnection pattern. After that, we can see the N channel with source, drain and body terminals. Hope you understand these topics of accumulation, depletion and inversion mode, and also the steps of NMOS transistor. Thank you.